In this video, we are going to learn about factor theorem. Before we proceed with factor theorem, I would like to introduce something that we have known. Let's say we have px is equals to x squared plus x minus 6. And if you want to factorize this, we will let x squared plus x minus 6 equals to 0. And then we will factorize x plus 3 and x minus 2 equals to 0. And then we have x plus 3 equals to 0, x equals to negative 3, and x minus 2 equals to 0, x is equals to 2. So I explained this because it's somehow related to this. You have to let it become 0, and then you say that the constant that you substitute here, and then you say x minus a, which the opposite, x plus 3, is a factor of the polynomial. In other words, if it is a factor, and when you substitute the constant into the polynomial, you will get 0. This is factor theorem. So let's try an example. If you have this factor theorem, and then you want to determine whether this linear function is a factor or not, so you will basically substitute, for this case, you will substitute x equals to negative 4. So p negative 4 here, you will substitute into the x, minus 3 negative 4 square minus negative 4 plus 3. And you get the value is negative 105. So since it's not 0, therefore x plus 4 is not a factor. Let's try for question B. So for this, you will substitute x is equals to 1 over 2. So p 1 over 2, you will put in the x, 1 over 2 cubed plus 13, 1 over 2 square minus 4. So when I use the calculator, I got it as 0. So I will say, therefore, 2x minus 1 is a factor. This is factor theorem. I will leave example 5c for your own practice, and I leave the answer for your reference.